It worked in mice. It worked in mice.
Welcome back to It Worked in Mice, the only health podcast that reads the science so you don't have to and then tells you why it probably won't affect you for another 20 years. I'm Alex.
And I'm Piper, here to inject a little hope into that cynical worldview of yours. Today, we're on a journey from the past to the future, from post-war sugar rationing all the way to a universal vaccine that sounds like it's straight out of science fiction.
Let me guess, it worked in mice.
It worked in mice. You're getting the hang of this. But let's start with something that worked in humans, sort of by accident. There's a new study looking at the long-term effects of sugar rationing in the UK after World War II.
Ah, the good old days, when the government forced you to be healthy. I bet everyone was miserable but had fantastic arteries. What's the takeaway? That we should all start lobbying for candy rationing?
Not exactly, but the results are pretty stunning. Researchers used this historical event as a natural experiment. They compared kids born before rationing ended in 1953 to those born right after. The ones who had their sugar intake restricted from conception until about age 2 had a 20 to 30% lower risk of heart attacks, strokes, and other cardiovascular diseases as adults.
20 to 30%? Okay, that's not nothing, but hold on. Life in 1952 was a bit different from life today. They weren't exactly avoiding high fructose corn syrup in their artisanal, organic, gluten-free kale smoothies. Their entire environment was different.
That's true, and the researchers accounted for a lot of that. They focused on this idea of the first 1,000 days of life, from conception to the second birthday, as this critical programming window for future health. This study gives us real-world, long-term human data, showing that what happens in that window with sugar has a massive impact decades later.
So the lesson is, don't give your baby a soda? Groundbreaking stuff, Piper. I think we figured that one out. My issue is, in 1952, you were rationed. Today, you have to actively fight a multi-billion-dollar industry that puts sugar in everything from bread to ketchup to baby food. It's not a fair comparison. The rationed group wasn't choosing broccoli over a donut. There just wasn't a donut to be had.
I see your point, but the principle is what's exciting. It's powerful evidence that early nutrition has lifelong consequences. It reinforces the current guidelines to avoid added sugars for infants and toddlers. It's not about blaming parents, it's about understanding the science so we can build a healthier foundation.
A foundation that we immediately start destroying with, well, everything else. Which actually brings me to our next little ray of sunshine. While we're worrying about the sugar we can see, what about the stuff we can't? What about forever chemicals?
Okay, so this next one is a little more sobering. A new study analyzed umbilical cord blood samples from babies born back in the early 2000s, and the findings are eye-opening.
Let me guess, they found more bad stuff than they thought they would. That seems to be the theme of modern science. We looked for the bad thing, and wow, we found even more of it.
Pretty much. They used a new, more advanced screening method that doesn't just look for a few specific chemicals. It scans for thousands at once. And in the cord blood, they detected 42 different PFAS compounds.
42? What are PFAS again? Remind me what I should be panicking about this week.
They're often called forever chemicals because they break down incredibly slowly in the environment and in our bodies. They're used in things like non-stick pans, stain-resistant carpets, waterproof jackets, even some food packaging.
Basically, everything that makes modern life convenient is secretly poisoning us from before we're even born. Fantastic. Just what I needed to hear. My Teflon pan and I were just starting to get along.
The optimistic take, Alex, is knowledge is power. We can't address a problem we can't measure. This kind of non-targeted analysis gives scientists a much clearer picture of what babies are actually being exposed to in the womb. It's the first step towards understanding potential health effects down the line, and eventually creating better regulations.
Regulations that will come into effect long before we're all 90% PFAS by body weight. It's a bit of a downer, isn't it? We start with eat less sugar as a baby and immediately pivot to, by the way, you were marinated in carpet chemicals before you even took your first breath. I'm starting to feel a bit overwhelmed by all these invisible threats.
It is a lot to take in. We're bombarded with information about diet, chemicals, genetics. It can feel like you're walking through a minefield.
You know what? All this talk of forever chemicals is making me want to go scrub everything in my house with vinegar and hope for the best. I think I need a moment. Let's take a quick break.
It worked in mice. Worked in mice. That sounds real nice.
Sounds real nice.
Will it work for you? Let's find out what's true. It worked in mice.
And we're back. Did you manage to decontaminate your entire apartment in that short break? Or did you just give up and embrace our chemical-filled destiny?
I settled for washing my hands and staring suspiciously at my frying pan. Let's move on. Please tell me you have something that doesn't involve prenatal doom or things that happened 70 years ago.
I do, and it's a big one. Let's talk about Alzheimer's. A team of scientists has developed a blood test that can estimate when a person is likely to start showing symptoms.
Okay, that sounds significant. How does it work? Is it reading your future in a drop of blood?
It's not quite that mystical. It measures a specific protein in the blood called p-tau 217. The levels of this protein are a mirror for the silent buildup of amyloid and tau plaques in the brain, which are the hallmarks of Alzheimer's. This buildup happens for years, sometimes decades, before any memory loss appears.
So this test basically gives you a countdown clock. It can tell you that symptoms are likely to begin in, say, 3 to 4 years?
Exactly. That's the accuracy they're reporting in the study.
I have to be honest, I'm not sure how I feel about that. On one hand, incredible science. On the other hand, what do you do with that information? There's no cure. Do you just spend the next 3 years waiting for the other shoe to drop? That sounds like a special kind of psychological torture.
I completely understand that reaction. It's a huge ethical question. But the researchers are looking at it from a different angle right now. The most immediate application is for clinical trials.
How so?
Think about it. To test a drug that's supposed to prevent or delay Alzheimer's, you need to enroll thousands of people and wait for years, maybe over a decade, to see if the drug group has fewer cases than the placebo group. It's incredibly slow and expensive. But with this test, they can enroll people who are on the verge of developing symptoms. The trials could be faster, smaller, and give us answers about potential treatments much more quickly.
Okay, from a research standpoint, that's the game changer. It dramatically speeds up the search for a cure, or at least an effective treatment. It moves it from a research tool to a personal diagnostic tool, though. That's a whole other can of worms for society to deal with.
For sure, but it's a step, a massive step, and it's way more accessible and cheaper than the current methods like brain scans or painful spinal taps. It's democratizing the research. Now, are you ready for the grand finale, the pièce de résistance of It Worked in Mice stories?
I'm braced. What is it this week? A pill that makes you love exercise? A patch that regrows hair?
Even better. Scientists at Stanford have created a universal nasal spray vaccine.
A universal what now? Universal against what? The common cold? Disappointment? My upstairs neighbor's loud music?
Close. In mice, it protected against a huge range of respiratory threats. We're talking SARS-CoV-2, other coronaviruses, common hospital-acquired bacteria like Staphylococcus, and even common allergens like house dust mites.
Hold on. You're telling me there's a single nasal spray that protects against COVID, the flu, bacterial pneumonia, and my dust allergy? That sounds less like science and more like a wish you make on a falling star. How does it even work?
That's the brilliant part. It doesn't target one specific bug like traditional vaccines. Instead, it supercharges the lung's own immune defenses. It puts the immune cells in your respiratory tract on high alert for months, ready to pounce on almost any invader that comes along, whether it's a virus, a bacterium, or an allergen.
So it's like giving your lungs their own personal security detail. That is genuinely impressive. Okay, I'll give you this one. Of course, it's only in mice. Call me when I can buy it at the pharmacy before my next flight. I'd pay a lot for a spray that prevents me from catching whatever the person in seat 14B is coughing up.
See, a glimmer of hope. Even you can't deny that's an exciting future to think about. A single shot, well, a single spray that could replace multiple yearly vaccines and protect us from the next pandemic threat before it even starts.
Fine, it's cool. A future with fewer shots and less sneezing is a future I can get behind. But it's still probably a decade away. For now, I'll just have to rely on not touching my face and hoping for the best.
And that's our show. From the long shadow of early life sugar to a blood test that can see the future of our brains, and finally, a nasal spray that might one day protect us from everything. It's a wild world out there in medical research.
And we'll be here next week to tell you all about the next incredible breakthrough that you absolutely cannot have yet. Until then, I'm Alex.
And I'm Piper. Stay curious.
This sounds real nice. Will it work for you? Let's find out what's true. It worked in mice.